Welcome to the video lecture series of electronic devices. This is lecture number 17 and today's topic is conductivity and mobility. So here you are going to derive a mathematical expression via which you can calculate conductivity, mobility and current density. Let us begin. You must have the knowledge of carrier concentrations in a solid because it is necessary for calculating current flow in the presence of electric and magnetic fields. At the same time, the values of N and P, it must be taken into the account the collisions of the charge carriers within the lattice and with the impurities. So these processes will affect the ease with which electrons and holes can flow through the crystal, that is their mobility within the solid. So charge carriers in a solid are in a constant motion even at thermal equilibrium. At room temperature, the thermal motion of an individual electron may be visualized as random scattering from lattice vibrations, impurities and other electrons and defects. So it has been assumed that even at room temperature there is certain thermal motion of an individual electron, and that motion can be visualized as a random scattering. So random thermal motion of electron in a solid can be viewed like if it is moving like this. It is not still. It is moving in a particular direction, and that direction is not easy to calculate. That is why we are saying its motion is random. So this is what the random thermal motion of electron in solid. And if we need to relate it with the drift velocity with which an applied electric field, let us say if the field applied electric field is in this direction, so this is the drift velocity with an applied electric field. Since scattering is random, there is no net motion of the group of n electrons because scattering is the random one over here. So if we are taking total n electrons per centimeter cube for a group, this is not true for individual electron. For individual electron, the condition may vary. If an electric field Ex is being applied in x direction, each electron experiences a net force which is minus q into Ex. This is the force on each electron. However, net motion of the group will be in minus x direction because electric field is in the x direction. So, net motion will be in minus x direction. If we say that Px, if Px denotes the x component of total momentum of group, x component of total momentum of group, then force in the field on an n electron means total force on n electrons can be written as, what would be this particular term? This will be what? Minus n, which is the total number of electrons, q into Ex. This is what? D Px upon dt because of the applied electric field. Initially, it seems from above equation, which is the equation number 1, that there is a continuous acceleration of electrons in minus x direction. However, this is not the case because net acceleration of equation 1 is just balanced in steady state by deceleration of the collision processes. Means overall acceleration is balanced by the deceleration process. It means to find out the total rate of momentum change, what you need to calculate? The total rate of momentum change let us consider a group of n naught electrons at time t it is equal to 0, and we must define n of t as number of electrons at that have not undergone a collision by the time t. So this is the number of electrons which have not gone under a collision. Therefore, the rate of decrease in nt at any time t, it will be proportional to number of electrons, number of left unscattered, this is what? Rate of decrease in nt. Because it is a rate of decrease in nt, so it would be minus d by dt of nt. So this particular equation you can write it as what? D by dt n of t, which is equal to 1 upon t bar n of t, where t bar dash, this is a constant of proportionality. From here, this equation number 2, you can determine the solution. So if you derive the solution from equation number 2, then you can write it as solution of equation 2. It will be an exponential function, means n of t is equal to n naught e raised to the power minus t upon t bar. Let us see question number 3. And here t bar is what? T bar is the mean time. This is the mean time between scattering events. Between scattering events. The probability that any electron has a collision in time interval dt is what? This probability will be dt upon t bar. Therefore, the differential change in px due to collision in time dt is what? Means now you are writing the differential change in px due to the collision in time interval dt. What would be this particular term? This will be d of px, which is equal to minus px dt upon t dash. Equation number 4. The rate of change of px due to the decelerating effect of collision. This particular rate means which is due to the decelerating of effect of the collision can be written as what? This term dpx upon dt, which is because of the collision. This will be what? This is minus px upon t bar. Let us write it as equation number 5. Moving ahead, for steady state, the sum of acceleration and decelerating must be 0, means both the sums will be 0. So from equation number 1 and 5 we can write as, from equation 1 and 5 taking into the account, we may write as minus px upon t bar minus n q ex is equal to 0, which is the equation number 6. And average momentum per electron, you can write average momentum per electron, it can be written as px. This is what? Total momentum px divided by the number of electrons, means this is minus q t bar ex. Here this bracket indicates this one. This bracket indicates average over the entire group of electrons. So you must remember, whenever you are writing the average over the entire group of electrons, you can mention this particular bracket. Now an average, therefore an average, a constant net velocity in x direction, means now you can calculate the constant net velocity in x direction this because overall group is moving in which direction? Minus x. So you must write the constant net velocity in minus x direction, and this can be written as Vx, and if you are calculating average, then it must be Px upon m n star, which is equal to minus q t bar upon mn ex. You are aware with the term mn, which is the effective mass. Now, individual electron move in many directions because of the thermal motion. You have studied that because of the scattering, individual electrons may move randomly. But equation number 8, this equation tells us that the net drift of an average electron in response to the electric field. So this is what? This is in reference to the average electron with reference to the applied electric field. Therefore, the current density, if you have to write down the current density, then this particular current density, because of this net drift total, this will be equal to what? You know that the current density is denoted by which term? Current density is denoted by J x. So I was telling it to you that current density is equal to the number of electrons crossing a unit area, which is n Vx into charge on the electron. What is the charge on the electron? Charge on the electron is minus q. So current density because of this net drift can be written from this particular equation. Therefore, you can say and you write Jx is what? Minus Qn into Vx, which is the net velocity. Let us write it equation number 9. Now using equation number 8, average velocity can be written as, just you manipulate the terms with the help of equation number 8, substitute the value of Vx in equation number 9. So you can write Jx is what? N q square t dash upon mn into Ex, which is the applied electric field. The current density is proportional to the electric field. Next, write down, note this particular point, that current density is proportional to the electric field. Therefore, Jx is what? It can be written from this term, where you can write the value of this as n q square t bar upon m into n, mn star, which is the effective mass. So with the help of equation number 10, and you know that the current density is proportional to the applied electric field, so from here you have written this particular term. So I hope from this particular term, from this particular equation, you are getting each and every step. Therefore, this term is known the conductivity. Therefore, you can write the conductivity as can be written as, this will be what? Q n into mu n, where this term mu n will be what? This is q T bar upon mn. See, just you have utilized this particular equation, and from here you have written the equation of the conductivity as well. So I hope now it must be clear to you, because conductivity is written as this particular equation. So if you are comparing this with this, then you will be getting how to write down the term for the mu n. And this quantity mu n is known as electron mobility. The quantity which is like you have written over here, mu n, this is the electron mobility. As I have told you that, what is this term? Mu n, this is the electron mobility. Here you have seen one term which is mn star. You know that this is the effective mass, but how to calculate this effective mass over here? This term can be calculated by using this particular equation, where it involves two terms. First is ml and second is mt. What is here ml and mt? Where ml is band curvature longitudinal, curvature longitudinal effective mass. And next term, which is mt, this is the effective mass along the major axis of ellipse. So by using this particular equation, you can calculate the value of effective mass. Moving ahead, the mobility. If we talk about the mobility can be expressed as the average particle drift velocity per unit electric field. So if we compare equation number 8 and equation number 12, then we can write what is mu n. This will be what? Minus Vx upon electric field, which is Ex. This is the equation number 13. Current density can be written in terms of mobility. So if you write the relationship between current density and mobility, you can write it as Jx will be what? Q n mu n into Ex. This is simply you have written over here. So here what we have considered only the electrons. But if we consider both electrons and holes, then you can write the equation as, in this particular case you have to take the consideration of both electrons and holes. So overall term for the current density, Jx will be what? Q n mu n Ex plus Q P mu P Ex. This is for electrons and this is for holes. You can just write it down into a simplified manner. Q Ex n of mu n plus P into mu P. So this is how you can write down the expression of current density by considering both electrons and holes in the process. So this is the final expression. You need to utilize this particular equation while solving a number of numerical questions. So you must remember all these formulas very well. So I hope now the concept of conductivity and mobility is clear to you, and you can write the equations for conductivity, mobility along with the current density and their relationship. Topic for the next class is drift and resistance. Thank you so much for today's class.